Let's visualize the bundt pan rotation. I've got my function typed in here, same way we did by hand. That's the top of the curve, and then the bottom region of the region is just y equals 0. We're going from 2 to 12.5 like we did, but here's the key idea. Now I've got the axis of rotation set to x equals 0, that's the y-axis, rather than to y equals 0 like we had before. So I'll show it the right way here, the way we're going to do it, and then I'll go back and show what happens. We used to have this set to be y equals 0, but we'll do it the way we want to begin with. So let's rotate the region here. So we're getting that shape that we wanted. And then if we ask it to show a representative rectangle and revolve that around, so here's where we're getting that shell rather than a disk or washer. And we can try that at smaller x values. And then so as we're doing the integral, we're adding up all these little shells. A little because each one is very, very thin, even though it has quite the large radius or maybe even a large height. So those are our shells. And we can also show, in this case, 4, or we can increase it a bit and revolve those around, and in some sense we're adding those up. All right, so the key idea here, let's not do that anymore. Like I said, we told that the axis of revolution is x equals 0. If I had said y equals 0, which was the default, if I just left it like that, and then rotate the region, then of course it rotates around the x-axis, which looks kind of like the spheres we did before, but that is not the bundt pan shape we want. Notice here that I was using y equals f of x, the same function we had here, so our usual way of specifying a function, rather than the x equals f of y option that we did when we were rotating stuff around the y-axis.